Miss Collier explains
Symmetry.
Today, our learning intention is to understand what a line of symmetry is, to be able to determine the order for the line of symmetry of a shape, to understand what rotational symmetry is, and to figure out the order of rotational symmetry for a shape. We will know we are successful when we can determine the line and rotational symmetry of a shape. Symmetry. I'm sure you already know a lot about symmetry and can think of many examples where symmetry is in everyday life. Today we're going to talk about two different types of symmetry, and here in a starfish and a sunflower we can see these two different types of symmetry reflected in different ways. We can see lots of symmetrical geometrical shapes in nature, and the starfish and the sunflower are just a couple of examples. Shapes such as these can have two types of symmetry, line symmetry and rotational symmetry. We can also get some other examples that are man-made, and some of them can seem really crazy and like they don't even have symmetry at all. This is called the Triskelion, and it's on the flag of the Isle of Man, and it actually has symmetry in it. But let's find out how. So an axis or a line of symmetry divides a shape into two equal parts. It acts as a mirror line with half of the shape being reflected on the other side. The order of the line of symmetry is the number of axes of symmetry that a shape has. On the other hand, the order of rotational symmetry is the number of times a shape makes an exact copy of itself in its original position after it rotates 360 degrees. If a shape is irregular and it never repeats itself the whole way round, so it has no rotational symmetry, we say the order of rotational symmetry is 1, because it always makes that original position one time. Finding the symmetry of shapes. Now when we're trying to do this, it's actually best if we have shapes in our hand that we can fold and we can turn and we can figure out the order of these different types of symmetries. So I'm going to flip the camera over and I'm going to do the line and rotational symmetry of a square.
To calculate reflectional symmetry, we need to figure out how many times we can fold the shape in half while it still makes an even on each side. So if I fold the square like this, we can see that it's creating the same shape on both sides, meaning that is one axis of reflectional symmetry. To figure out the order of reflectional symmetry, I figure out how many times can I fold it. So that's 2 and 3 and 4. Any other way I tried to fold it, it would not create an even on both sides, meaning it's not an axis of symmetry. So my reflectional symmetry is 4. To figure out my rotational symmetry, I need to draw around my shape. So I take my shape and put it at a starting position and then draw around the edge. It doesn't need to be perfect, but it just needs to show my shape. Now that I've got that drawing, I now need to see how many times my shape fits inside the square, or now that I have that shape, I need to figure out how many times does my shape fit inside the outline as I turn it. So I've got 1, 2, 3, 4. So that's 4. Make sure you either only count the start or at the end. You don't count the start and the end. So that's a rotational symmetry of 4. Remember that if you've got a shape that never looks the same unless it gets back to the start, it's not a rotational symmetry of 0, it is a rotational order of 1, because it still has that one time when it gets back to the start and is the same shape.
Now you try. Find the line and rotational symmetry of a whole bunch of other shapes. I hope now you can determine the line and rotational symmetry of shapes.